Atmospheric effects. The impact to air quality from pollutants is dependent on several factors, including the type, amount, and concentration of the pollutants, as well as the atmospheric conditions at the time of the release. This week we will briefly discuss some of the major impacts to air and the agents that cause these effects. Visibility. The obstruction of light due to foreign bodies in the atmosphere is one of the more obvious results of some pollutants. Smoke, made up of gases, vapors, and particulates, can all contribute to reduced visibility, but more importantly can impact those exposed to these emissions. There are strict limits on air pollution sources that create these sources of air pollutants. Sources that contribute to visible air pollutants include diesel-fired boilers, cruise ships that operate on heavy crude oil, and wildfires. Acid deposition. pH is a scale of the hydrogen ion activity. A pH of 7 is neutral, and all values below 7 are considered acidic, and above 7 are basic or alkaline. The scale is logarithmic, so for every increment of 1, the actual change is 10 times. That is, a pH of 6 is 10 times more acidic than 7, and a pH of 5 is 100 times more acidic than 7. Acidic deposition is a secondary air pollutant. It is formed when oxides of sulfur or nitrogen are emitted into the air and combine with water vapor to form sulfuric and or nitric acid. Sulfur. Oxides of sulfur include several forms, including SO2. Power plants contribute more than 70%, and other industries produce about 20% of these emissions. Like most air pollutants, exposure to oxides of sulfur may result in respiratory distress and disease. SO2 can react with other compounds, including particulates. These particulates can deeply penetrate the respiratory system and aggravate existing diseases or create new ailments, including emphysema and bronchitis. SO2 can also react with water vapor to form acidic deposition in the form of sulfuric acid. Nitrogen dioxide is the most notable of the air pollutants. It is referred to as NOx, where X can be 1, 2, or 3 oxygen atoms. NOx is created by emissions from vehicles and power plants operated on fossil fuels. NOx is a major contributor to ground level ozone, also known as smog, as well as acid rain. Oxides of carbon. There are two main forms, carbon dioxide, CO, and carbon dioxide, CO2. They are both created by the combustion of fuels. Carbon dioxide was one of the original pollutants regulated by the modern Clean Air Act. CO2 is dangerous as it has a greater affinity for hemoglobin than oxygen. It is an odorless and colorless gas that one can be exposed to without knowing it. CO2 is a primary global warming gas, and we'll spend much more time on this and other global climate change compounds in later chapters. Mercury. Mercury exposure can result in both short-term and long-term health effects. Small amounts of mercury are found in coal, and when this coal is used for energy production, mercury vapors can be released. Mercury is hazardous only in an organic form. Methylmercury is created when elemental mercury, which is relatively harmless, is converted to methylmercury by microorganisms. There is a national network of mercury sampling stations to measure the amount of mercury in the atmosphere. Eventually, the mercury settles out and contaminates soil and aquatic systems. Stratospheric ozone depletion. The stratospheric ozone layer protects many of the Earth's biological systems from harmful ultraviolet radiation. The ozone layer has been harmed by man-made chemicals, primarily chlorofluorocarbons, CFCs, and other halogenated hydrocarbons. These compounds were used as industrial cleaning solvents and refrigerants. NASA discovered a hole in the ozone over Antarctica in the 1970s. When the cause of this hole was discovered, an international treaty, the Montreal Protocol, was signed where the signature countries agreed on a timetable to eliminate these compounds that broke down the ozone. Although the treaty has been successful, the long life of the CFCs already released, and the fact that the original replacement chemicals also harm the ozone layer, but to a much lesser degree, means there will continue to be a degradation of the ozone hole, although it has improved since the treaty was put into effect. Global climate change. The most serious air pollution issue is global climate change. Gases that retain some of the heat from the sun moderate the temperature of the Earth. In fact, without these gases, the Earth could not support life as it exists. These gases include carbon dioxide and water vapor. However, since the start of the Industrial Revolution, the man-made emissions of global climate change gases such as CO2 and methane have altered the climate, raising average temperature by 1.5 degrees centigrade and increasing water levels. It is important to note that global climate change is the best term to describe this situation. Global warming implies a uniform heating across the globe, where in reality, some areas will be affected more than others. Extreme weather of hot and cold, and precipitation and drought will be more common and wreak havoc. The only way to minimize the impact will be to reduce the emissions of these compounds responsible for global climate change.